Hi, it's Ted Ritzer with the Greening Government Speakers Series. I'm the host for the lunch hour here with David Gray. Is our partner in crime is the Municipal Climate Change Action Center, and we're lucky to have David Gray speak to us from his office in, I think maybe it's South Edmonton. I'm not sure, but
we're West Edmonton.
Oh, West Edmonton. Okay, well, to do justice to David's expertise, the topic is energy innovation, and David's an experienced energy and regulatory economist who's been active in the energy and utility sector in Alberta since 1998. He's previously worked as a senior analyst at the AEUB and was an executive director of the Office of the Utilities Consumer Advocate. Since 2010, David has been at the forefront of commercial and industrial energy efficiency and energy cost management. And David was president of CCW Inc., an innovative company producing regenerative motor drives for oilfield pumping. So you're in the thick of the oil patch, David. And also since 2012, he's co-founded AIM Energy Pros, a company doing state-of-the-art energy efficiency evaluations for commercial and industrial clients. And he's a frequent commentator on energy matters in Alberta, appearing frequently at professional conferences and in the press. And you had just mentioned when we were chatting prior to broadcast here, David, that you had done a little consulting for the government of China, and also you had recently attended an international conference. So with that said, I'll let you get started here, David. Thanks so much.
Well, thanks, Ted. That's a heck of an introduction. I appreciate it, and thank you very much for having me on this series. I'm really delighted to have a chance to talk with you and all the other folks in government about some of the things that are going on in terms of innovation in the energy industry, and particularly how that applies to us in Alberta. So if I may, what I sort of plan to do is to split this into two parts. The first part was government as policymaker and what can be done there to aid our market and our particular situation in terms of energy efficiency and innovation, and then switch over to talking about government as one of the largest consumers of energy in the province and things that we can do there. So with that, let me just fire up the slideshow. And just before I do that, I was mentioning to Ted that the thing in the background, you notice there's a sword of ancient coins that was given to me by the Chinese government for doing a seminar for them on energy regulation and energy markets. I'm not sure that it made a whole heck of a lot of difference. They've got much bigger problems than us, but nevertheless, just so you know what it is. So with that, just let me fire up the slideshow and we'll start going through this presentation. And there we are. Is that coming through, Ted? So with this, I wanted to
So David, I think you're going to have to retry that in terms of share screen. I'm not seeing your slide, sorry.
Okay, well, let's just do this again. Oh, interesting. Okay. Well, let's just get to that. Have you ever noticed that technology always works better in practice than it does?
That's always the case.
Anyway, let me get to it here. Come on, baby. Is that there now?
I'm not seeing it, David. Maybe I should, maybe I'll take control of the screen and then you take it from me, okay? So
Sure.
I'm just clicking on share screen, and then I'll ask you to take control and share screen from me.
We can edit all of this out in post, right?
Okay, so I've taken control of the screen, and if you click on share now, David, and okay, and then if you just maximize your slide.
How is that?
Looks good. I'll just mute my mic now for you.
Thanks, Ted. Appreciate the technical assistance. So this is a continuation of the Greening Government series. And what I'd like to talk to you today is about the options for government. First as a policymaker, and then second as a consumer of energy. So the way I've laid it out is to talk first about the landscape. One of the challenges in Alberta is that we have a very unique landscape. We've transitioned from a fully regulated utility system to this mixed mode of fully regulated transmission and distribution companies with market-based energy providers. But in order to give everyone the flavor of how this works, I wanted to go back a bit in time to the day of fully regulated utilities and talk about the economics of those companies. And it's really simpler than people think. There are only 5 things that regulated utilities can charge for. They can charge for their operating expenses, they can charge for their taxes, they charge for depreciation of the assets that they have in use for public service, otherwise known as rate base. They can charge for the interest on debt, and they can charge for return on equity. Now, people with an accounting background will realize the only place where they actually make a profit is in their return on equity. And this has a big impact on what utilities try and do and the strategies that they use to maximize their own value. So utility companies can increase their profit before the rate maker, before the regulator, in this case our Alberta Utilities Commission. That's the only place they make extra profit. If you think of any other sort of company, they can advertise, they can do marketing, they can do promotions. A utility company already has given or has been given 100% of the customers. They can't increase the amount of customers they have. They have them all. So the only thing that they can do is go before the regulator to plead their case that they should be making more money. And some of the common strategies that they use to do this is to push for increasing the amount of investment they have in capital rate base, plant and equipment. They can also under forecast the demand for their product, or they can over forecast the risk of them staying in business. This relates into the amount of money that they're granted for return on equity, which, as I just mentioned, is the only place they make any money. So utility companies are kind of unique, and you can't really understand them until you get, into the rate room, the rate hearing room, and understand what's going on there. I had the advantage while I was with the Office of the Utilities Consumer Advocate that I was in, rough numbers, about 100 rate hearings in great gory detail, and overall in about 1,000 different proceedings. So it was an excellent experience for me to really get to the bottom of what utilities are looking for, what they like to do, and how they like to operate. So with that as a basis, we now have to move forward to what we have now, which is regulated utilities in a market setting. Alberta has a very much made in Alberta system. It's not like anyone else's exactly. Our closest analog is Texas, that has a similar sort of electricity market and gas market. We have developed this mixed market structure where electric generation and retailing and gas production and retailing are both market-based, while the distribution and transmission functions are still fully regulated and provided by regulated utilities. Now, one of the more recent wrinkles in the way things are done here is that most utilities, under the direction of the Alberta Utilities Commission, have moved to what's called a performance-based rate-making plan. And essentially what that is a plan for multiple years of operation, typically 3 to 5, where the growth rate of the utilities rates is capped, and out of that is deducted an expected amount of efficiency improvement. The notion behind that is that it gives utility companies more of an incentive to improve. It doesn't keep them in the hearing room focusing on just that aspect of their operations as the most important one, but forces them to try and be more innovative and efficient in their operation. Now, there are some real world challenges with that I'll come back to. So our energy markets, I'm talking about gas and electricity here. Natural gas has been deregulated far longer than electricity, and it's been based on market prices since 1995. The key aspect of the natural gas market is that it's transcontinental. The price is set based on the demand for gas, not just here, but in the northeast of the United States, Chicago, and other places across the continent that make it a very liquid and very competitive market. Our electricity market is very different. It's really an island in Alberta. We don't have very strong interconnections with our neighboring jurisdictions. Our neighboring jurisdictions haven't moved towards a market-based type of system. They're still fully regulated from top to bottom, or fully integrated, as they like to say. And so we've ended up with this island of an electricity market that's different from most in that it only really pays on the amount of energy that's produced. In other markets, they will split the charges up between the amount of energy that's produced and typically what's called a capacity fee, which is where you're paid to be available to operate. Otherwise known as a capacity market. Ours is energy only, and this has some significant ramifications on the way the market operates. The key factor for us here is that our electricity market is really dominated by 5 companies. They have different objectives in mind, but you'll see typically when our market prices spike here, it's because the largest player, which is TransCanada, has decided they want to run the price up, and they do that by pricing the output from the plants they control at a very high level, knowing they're not going to generate all of that power, but knowing they'll make it up on the price. We have the most volatile market for any commodity on the planet for electricity in Alberta. And you see that when the price goes from 2 cents a kilowatt hour to 99 cents a kilowatt hour in the course of half an hour. It's really a very different type of market, and there's lots of moving pieces to it that really need to be understood when making policy. So what I wanted to spend the most time on here was talking about the available levers for government. The challenge to enact the proposed climate leadership strategy, sorry, I'm just picking it off my desk, is that our electricity market has no levers for government. Essentially, it's been set up as a completely market-based, competitive operation where the private generators decide what to build, when to build it, and what price they need before those things happen. There's no capacity for the government to regulate what needs to be built, when it needs to be built, et cetera, et cetera. The challenge for that is in terms of directing the market away from coal-fired generation towards green generation, which is the stated aim of the plan. And to my mind, there's one easy way to do that, and that is to add a capacity market to our system. The notion of a capacity market, which is essentially just standby payments. Right, I'm going to pay you X number of dollars per month for you to be available to generate. That's been proposed for the green generation that's supposed to make up 30% of our market within the paper. It's acknowledged that left to its own devices, the electricity market here won't provide enough return to incent wind generators or solar generators or geothermal generators to build in Alberta. You just can't make a business case for it. It's too uncertain. And so the notion there is that we'll provide an additional payment that will be based on some sort of a competitive process for people to get in line to build these generators. Now, the notion that I would like to explore, and I'll explore that a bit more in a second, is that that should actually be applied not just to green generation, but also to thermal generation, so that we have reliability. This goes back to my days when I first started in the electricity business. The primary consideration for electricity is reliability. If you think that electricity at $1 a kilowatt hour is expensive, well, not having electricity is many times more expensive. When they had the big blackout in northeastern United States back in 2003, they estimated that the costs to society were about $5.50 US per kilowatt hour lost in terms of spoiled food, lost work, all the things that grind to a shuddering halt when we don't have electricity. And if you really want to scare yourself, go look up the CNN movie on blackout. If we don't have power, we're really dead in the water. In our society, we assume that electricity is always going to be there. And when it goes out, the utility companies work like hell to get it back on. It's that important. Now, the one thing the government does have full control over is regulated utility operations. It's often been said that regulated utilities are creatures of statute. If it isn't written down, they can't do it. And so there is opportunity there for the government to direct those companies to do the things they want to do. So with that, I wanted to get into some practical examples of what those policies could look like. I've already talked about the first one at some length, which is to add a capacity market for all generation. My own belief is that without a capacity market, our energy-only market will not provide reliable generation. I say this because of the other example we have of an energy-only market in North America, which is in Texas. Texas has had the issue of trying to deal with growth, the same as we have. They have a very large western section of Texas that produces all sorts of wind generation. And they're seeing the same thing as us, which is that when you add wind generation, which in terms of the market dynamics is a big random number generator, to a thermal-based system, what you do most of the time is drive the price towards zero. And because Texas is larger and more competitive, they're also finding that competition within the generation thermal electricity or thermal generation market is so competitive that it's driving the price towards marginal cost. Now, it's pretty obvious that if your returns are based on either zero or marginal cost, it's awfully difficult to make the case to build new power plants. So Texas has been struggling with how do you incent people to bring on new generation in time to maintain a reasonable reserve ratio. They have been talking about capacity markets, but for the moment what they've done is gone down another path, which is to greatly increase the maximum charges for electricity. So in Texas, you can see the market run up to $10 a kilowatt hour. Now, you think about that for a sec. If you ran your kettle for an hour, it would take over $10 worth of electricity. It's incredibly expensive whenever they run into shortage. And even with that, they're concerned about not having reliable generation for Texas. So enough said about that. Hopefully someone asks some questions as we get towards the end. We can make sure that everybody gets what I'm trying to lay down there. The second thing that I think we can look at in terms of policy options is to adopt blanket energy efficiency incentives. One of the biggest concerns I have in terms of energy efficiency incentives is what I've seen in all sorts of other jurisdictions. I happened to attend the conference in Long Beach over the summer. It's called the International Energy Program Evaluation Conference. Happens once every 2 years in North America. It was all of the utility companies from across the United States, several from across Canada. I was the only Alberta representative. And then all of their regulators. And what I saw time and time again was an enormous amount of time and effort spent in trying to create individual programs for individual pieces of technology that were often out of date. And I'll give you a classic example. California just wrote into law that fluorescent lighting in office buildings needs to be dimmable. The problem with that is that's a very out-of-date technology. Dimming fluorescent lighting doesn't work very well. You can often dim the output of the lights without actually saving any energy, and you may in fact see the energy use increase while you're trying to dim them. It's a very poor technology selection, but it's taken them so long to get that through that by the time they got it into law, it's out of date. If instead they said that everyone needs to put in LEDs, it would have had probably 10 times the impact. And the other beauty with LEDs is that they're infinitely dimmable, and the energy use is a direct straight line function of how much light they're putting out. So that's my particular concern here, is that we really should be looking at something that pays per kilowatt hour, per gigajoule of gas, per therm, per joule, set a standard and let people use their innovation. One of the things that makes me happiest is I get to travel the world and look for all sorts of new cool things, one of which I'll show you here this afternoon. But there's a tremendous amount of innovation going on. We need to benefit from it. And creating elaborate individual programs will do nothing but slow that down. The third thing I'll put out there as an option would be to allow non-utility metering. There was consideration given back in 2007 when I was still inside government of taking away the monopoly of electric utilities on metering. They backed away from that, and I really wish they hadn't. The reason is that the energy meter is the key piece of infrastructure that you need in order to make smart technology work. So many of you may have heard about smart grid. Well, the problem is that utilities aren't really doing smart grid. They're kind of doing advanced dumb grid. They've spent an awful lot of money on metering. Because of the type of meters they use, they're very much more expensive and less capable than other ones that are on the market. And me, for example, coming in to try and put in smart technology in your office building to shave your peak demand or integrate solar into your facility, I can't use their meter to drive your equipment. So I think it's an area where you would instantly open up all sorts of options for new technology and new entrants to the market to get us to the state of the art. The last thing I'm going to put out there, because this was raised in the climate leadership paper, was that utilities should not participate in energy efficiency programs. The notion there was that utility companies have a perverse incentive. They don't actually want to reduce demand. And I understand that. When I was with a utility company, every time I came up with a good demand-side management program for some of our industrial customers, the CFO would review it and we'd get another 1,000 fridge magnets. I understand the perverse incentive, but we have two things that are sort of separate and distinct here right now. The first is that with utility companies being under performance-based rate-making structures, there are actually ways to accommodate the change in consumption such that the utilities are held whole and don't get harmed by energy efficiency and programs. The second part of it is that utility companies are really, really good at one thing, and that's raising cheap money. Because utility companies have this regulated monopoly, they are golden when it comes to getting money from the debt markets. When you look at our utility companies, they typically have a AAA credit rating, which is as good at or better than the government's. So I just throw these out not as an exhaustive list, but just as some options to talk about as to how we can move forward and make things better. Now with that, I'm going to switch over to government as consumer. We deal now with many municipal governments in particular in trying to bring energy efficiency programs in for them that make sense. The Alberta government and the Alberta and municipal governments combined are, pretty much one of the largest energy consumers in Alberta. What you can do would actually move the market if you were so inclined. But I think the key thing for government to look at is how not just to be in the forefront of energy conservation for the sake of energy conservation, but how can you take that tack and then use it for cost savings so that you can take money out of what you're spending now on energy and put it into other programs that are more valuable to us all. So my contention is that government, and this is like most consumers, has not really taken an integrated view to energy purchasing and energy usage. My best example is LED lighting. And if you look at LED lighting as the amount of dollars you need to spend for the amount of kilowatt hours you'll save, what you'll find is that it works out to between 1 and 2 cents per kilowatt hour. Yet people are reluctant to go ahead and do this because the upfront costs are high compared with replacing fluorescent bulbs or incandescent bulbs or compact fluorescent bulbs. But what they don't get is that if you're not buying energy efficiency, or what I like to call not energy, you have to buy energy. And in buying that energy, you're buying it typically at about 10 cents a kilowatt hour by the time you add in the energy costs plus all of the distribution and transmission charges. Those charges are going up. Transmission charges alone are probably going to go up by 50 or 60% in the next 3 years. So there's a strong incentive to buy not energy as compared with energy. And it's really something that I hope I can help you with, to develop a plan such that the purchase of energy is integrated with the purchase of energy efficiency and energy management devices such that you get the best bang for your buck. You don't need to do it to save the planet. You can just do it to save your budget. So with that, I just wanted to talk about a few options, and then I was going to do just a little show and tell with a new product that's just come into Alberta that is very, very cool. So my own recommendation for government as to how to do this best would be to look at benchmarking and monitoring government buildings by usage and type to try and find the low-hanging fruit. I can guarantee that if you went and looked at all of the hockey rinks across Alberta, you will find in each one of them 1 or 2 motors that are running at almost 100 degrees C. We have a little collection that we've made just of red hot motors. Those particular motors, as they fail, start consuming double or triple the amount of energy that they should be using. And they're turning it into heat, which is not useful, rather than motion. Starting with a benchmark is a good way to look at whether or not your particular facility or the facilities you're responsible for are good candidates for the places to start. The second one I'd like to talk about is converting to LED lighting. I'm going to be honest, at this point in time, LED lighting has advanced to the point where it should be pretty much a no-brainer. It pays off in most instances in under a year. And there are a number of companies in Alberta that are getting to be really, really good at not just replacing what's existing, but in replacing it, making it better by doing things like balancing the color that's coming out of the lights so that it's easier to work under, and doing what's called light harvesting, where your light levels that are produced by your artificial lighting actually are reduced as sunlight comes in the windows. It's a very smart thing to do, and as I mentioned before, LED lighting is fantastic for being able to dim it and actually save energy. I'm going to skip to the last one, which is to use a smart power bar. If you've never seen them, they're a power bar that has one plug that is the master. And so whatever is plugged into that, as you turn it on or off, turns on or off everything else that's plugged into that bar. It's a really cheap and cheerful way to stop losing energy to what they call phantom load, which are usually the little transformers that you get to convert 120 volt AC power into whatever your devices need. They're terrible little things, mostly useful for turning electricity into heat. The last one I'm going to use or talk about is to use phase change materials, and I'll finish up the slide, so just go to the last slide, which is just how to get a hold of me. I'm going to suggest if you are on LinkedIn, get a hold of me on LinkedIn. The reason I say that is I post blogs 2 to 3 times a week on energy matters, and you may find some of them interesting. I wrote a little one a while ago about why the Alberta electricity market is going to fail. I think so far I'm up to about 900 views on that one. So I've got 1,200 friends around North America that go back and forth with me on energy stuff, and it's the best place to get a hold of me. But with that, let me stop the show and go to my show and tell. Ted, am I back? Can you see me?
Yes, I can.
Fantastic. I'm going to show you something which is very, very sciencey. This is called PCM, which stands for phase change material. And what it is a programmed wax. You'll see on this one, which is rated at 23 degrees C, this one is melted. It's all squidgy. What's happened is this has changed phase. It's gone from solid to liquid. And the way this manufacturer puts it together, they actually turn it into a gel. So if you happen to stick a pin through it, it's not going to leak out. This is the same brand of material, but one rated at 27 degrees C, and it's still hard as a rock. It's a solid. Now you're going to ask, well, what does that have to do with, anything? Well, what this is a smart thermal storage material. So how this gets installed is usually it gets put on top of suspended ceilings and retrofit, or if you're building new, it gets installed behind the drywall and behind the vapor barrier. And what it will do is as the temperature increases, it will get to the set point, which in this case, the squidgy one, is 23 degrees Celsius. And as soon as it gets there, this material will start to absorb a tremendous amount of latent heat. And in doing that, what it does is essentially act as energy-free air conditioning. So think about it in the summer, as the building's warming up during the day, instead of actually warming up the interior air of the building, energy gets absorbed into this, and it stays at 23 degrees C until it's completely melted, and then it will start to rise again. But in doing that, what it allows you to do is to actually cool your building without using any compressors, without using air conditioning. Now, in the wintertime, it has another effect, which is to reduce your peak day demand. So the way you get charged for gas, if you're a large commercial or industrial customer, is most of your distribution and transmission charges are a function of your highest peak day usage in the last year. So by having this installed in the wintertime, it maintains a more stable temperature, and in doing so reduces the peak day usage. So it's really very cool, and I'm hoping that we get to use this all over Alberta. Our initial tests are that it reduces air conditioning load by 40 to 50%, and we're still waiting for it to get cold around here so we can figure out how much it's going to save on peak day gas usage. But with that, that's my show and tell, that's my presentation, and I'm hoping that there's some questions that we can get to illuminate this a little further.
Okay, so for webinar participants, if you hover your cursor in the upper left-hand quadrant of your screen, you should see a Q&A function, and there's also a chat function. I'll open those windows, David, so I'll take a look to see if anyone posts some questions. But that last one is a pretty interesting idea in terms of both helping you out in the winter and in the summer.
So this stuff, it's half an inch thick, but in terms of thermal mass, it's like 10 inches of concrete. At that particular temperature, it will absorb as much energy as 10 inches of concrete.
Oh, right on.
Science, Ted.
Absolutely. Well, I'm monitoring the chat window, or at least sending a message there so that people can kind of see the window. We got, okay. Other things in terms of maybe the focus, obviously, of this presentation, David, was on sort of what government can do. And I think you mentioned maybe the smart grids aren't so smart. I found that of interest in terms of, is there any other comment you want to make on smart grids within for smart grids for maybe smart government buildings?
Well, all of the smart grid technology has actually developed to be used by enterprises rather than the distribution companies, and that's kind of too bad. Solar City, the company that Elon Musk is a part of in California, actually put out a really good paper that mixed the engineering aspects of smart grid technology with the economics and the regulatory aspects of it. It's a really good read if you're into that sort of geeky stuff. But the basic notion is this: when you look at things that are distributed energy resources, which are principally things like solar, microgeneration, and batteries, utility companies, instead of investing in new transformers and bigger conductor whenever they need to increase the capacity on the grid, should be looking first to reducing the peak usage. Because the funny thing is that our grids are designed not for the average usage, but for that 1 or 2 times a year, those few hours where you really hit a spike. If you look at what's typically called the load profile, it's a curve that sort of looks like that. And it's when you take all of the energy usage on a system or in a building over a year and rearrange them from lowest usage to highest usage, you'll see 2 things. That there's a broad central part where it doesn't change very much, and then there's 2 tails, one up and one down, where for a small fraction of the time, very few things are running, and for a small fraction of the time, everything is running. We plan our systems on the basis of when everything is running. And if instead of trying to solve that with a global solution, you actually looked at bringing in available commercial and market-based solutions into the distribution planning process, you could cut back the cost of your distribution system and make it last much longer and save everybody money. Right, but that would be the ideal of smart grid, would be that utility companies themselves are looking for opportunities to deploy new technology that will cut the cost for everyone. And that isn't happening. And the reason is they have little incentive to do it. Mm-hmm. But as I also said, the government has complete and utter control over anything that utility companies do. So if they wanted to, it could happen tomorrow.
Well, the other comment that I found fascinating was it's almost like government buildings, and if you look at all 3 levels of government buildings within Alberta, the ability to somehow incent governments at all levels to operate those buildings more efficiently, and for one, obvious when you mentioned the LED lighting, but what other things should we be considering at all levels of government, David?
Well, I mean, certainly one is joint purchasing of energy from the market. That, to my mind, would be a simple way to add an effective counterparty to the market power of the small number of generators we've got. But, the funny thing is that I know every March, if you don't have money that you're trying to burn through to, match your budget, then you're looking for places to find money, right? In every building you've got, there's probably 10 or 15% of your energy operating budget that can be saved within a year, right? Like we're at that stage now with energy efficiency that it's cost effective and really quickly cost effective.
Well, I guess I would encourage our participants to post questions. If you've got some specific questions that you want David to address, please post them. Just give the folks a few moments, David, to consider that.
Sure. Well, let me just go back and forth with you a bit, Ted. Were there any other things that made you pause, or for example, did you know how utilities worked?
Well, no, not at all. And I think the average government employee is like the average citizen, in that we understand implications to our home heating costs, but we're unaware of what can be done related to our places of work and, I mean, the energy expenditures that government makes every year, So I think as far as understanding what can sort of incent governments at all levels is really pretty fascinating, and something that the average government worker, I don't think is really, I'm certainly not, I don't understand that. So I found that of a real benefit to try and think through, from at any level of government, what they can do to sort of reduce carbon footprint, reduce energy consumption, all of those things. So, yeah, no, I think it's been good.
So for us, because we're in commercial and industrial energy efficiency, that's our bread and butter, we put it this way: we're trying to save the planet one CFO at a time, right? We concentrate first and foremost on energy cost efficiency, which isn't necessarily energy efficiency, and I'll make that distinction. So if you do LED lighting, that's energy efficiency. You're reducing your energy consumption. Now, what people don't tend to think about is that if you're in a commercial building, it's also reducing your peak demand. And so you get an additional benefit beyond just the 8 cents a kilowatt hour for energy in terms of your overall bill. But there are other things you can do to reduce peak demand that don't actually save any energy. A good example, and one that's going to become more prevalent, is the use of battery systems to manage peak demand. They're not actually going to save any energy. They're going to move it around, right? So you're going to store energy in batteries over here so that when you go to use it in your hour of peak demand, you can reduce your peak usage. And that has a big effect on your bill. To give you a notion, the charges for demand for distribution and transmission in Alberta range from about $170 per kilowatt a year to $220 per kilowatt a year. And it doesn't take very long for that to add up. We have one client, sawmill in northern Alberta, that's going to save $50,000 a year on that, right? With their one, and this isn't a big sawmill, this is a relatively small one, about a megawatt. There are other things you can do than just energy efficiency to reduce the cost of operating. And I really encourage government to do that, because I would very much like you to be able to do the things that are good for us all without having to raise my taxes, right? I think we're all in that same boat, right? There are ways that you can be more efficient, and it would not really be that hard to lay out a really simple program to go through, have the people that are responsible in accounts payable look at bills, give them the 4 or 5 things they need to look at, and identify pretty quickly the opportunities there for cost savings for government.
No, that's excellent, David. So I think thanks so much for taking the time to present to us. And I would just remind our webinar audience that we've got another session going tomorrow over the lunch hour with Dustin Bear and permaculture in education, growing food in urban areas. Thanks so much, David, for presenting. It was excellent.
Thanks for having me, Ted. Appreciate it. And, best of the season to all of you. I've been inside of government and have a fantastic appreciation for the hard work that gets done. I have also a fantastic appreciation for some of the challenges and frustrations. So with that, best of the season to one and all.
Absolutely. Thanks so much, David.
Thanks, Ted.
Take care. Bye.
Bye now.